Okay, so in this video I'm going to do a couple of examples of hypothesis tests. This is almost at the end of an intro to statistics course. And I'm going to use technology to find the p-values. So in this problem it says the average production of peanuts in the state of Virginia is 3,000 pounds per acre. And a new plant has been developed and is tested on 60 plots of land. And this new plant gave 3,120 pounds of peanuts per acre, with this standard deviation of 578. Using alpha 05, can one conclude that the average production has increased? So the first thing we do in this problem is to set up the hypothesis. So the nu, the H0, and the HA. I have to read that from the problem. So it says the question is asking, can we conclude that the average production has increased? Has increased mean that the mean is going to be bigger than the 3,000 that was given. And if you recall, this means that this is, because it does not include the equal sign, this is the alternative hypothesis, which means the complement, the one that includes the equal sign, which would mean the mean is less than or equal to 3,000, would be the null hypothesis, the H0. So if it didn't increase, it means it stayed the same or decreased. So one of these two is the claim we want to test, and I'm going to write it down like this one. So the claim is HA, right? That we're testing if the average production increased. It's more than 3,000. So the claim is not HO, is HA. Okay, now let's check the hypothesis of which test I should be using. Should I be using the Z or the T test? Let's check this out. So the sample I'm getting is 60 plots of land. So N is more than 30. I do not know the population follows the normal, but I do know that the sample is big enough. It's 60. And I'm getting the sample mean to be 3,120. And I do not know the population standard deviation. So this is unknown, because what is given is the standard deviation of the sample. So Sx is 578. So if you follow the flow chart, is the population normal distributed? No, but the sample is more than 30, so I'm here. Do I know the standard deviation? No, so I'm here. I use the t-distribution. So this is the chart for the confidence intervals, but it's the same approach. So I'll be using the t-test. So I use a t-test. Now I'm going to just use technology to get these values. So I'm going to use my calculator, my ClassCalc, right here. And it's very simple. Just click on, be sure that you're using the graphing calculator up here, and then press the stat, test, and the second column says t-test, and I input the data asked in that order. So the mu is the hypothesis mean, which is 3,000. Then they want the sample mean, which is 3,120. Then they want the sample standard deviation, which is 578. And then they ask for the sample size, which is 60. So my p-value now have to look the direction of always the alternative hypothesis. So my alternative is given here as greater than. So I need to put here in this row right here, that's the three possible p-values. And because the alternative is greater than, it's the second value. So the p-value is 0.5. So the p-value that I'm getting is 0.0566. I'm running to 4 decimals. Now this is barely, but it is bigger than our alpha. Alpha was 0.5. So this is bigger than alpha. The tolerance, the low significance was 5%. So this is the case where we do not reject if the p-value is bigger than alpha. Always, this is in base of H0. So we do not reject the null hypothesis, but remember that null hypothesis was not our claim. The claim was alternative. So since we are not rejecting the null hypothesis, we reject the claim. So we don't have evidence to support that the claim that average production has increased. Okay, so this, my final conclusion is this box down here is probably right. Reject the claim that the average yield has increased. Okay, so this one used the t-test because I do not know the sample standard, the population standard deviation. I'm using the sample one. I can use it because my sample is big enough. Okay, my next example in this video is going to be a car dealer recommends that transmissions be serviced before the car hits 32,000 miles. To see whether the customers are following the recommendation, they select a sample of 25 customers and found that the average mileage was 33,150. From previous studies, they have an estimate of the standard deviation of the population, right? It's giving us sigma, 1650. And we can also assume that the population follows a normal distribution. So in this case, the sample is not more than 30, but it is normal distributed. Do I know the standard deviation population? I do. So now I'm going to land in this part over here. I'm going to use the z-test. So on this one, I'm using the z-test. Oops, sorry. I'm using the z-test. Why? Because sigma is known. And population follows a normal distribution. Sorry, I don't want to keep my calculator there, so I'm writing a little bit smaller. Sorry about that. So this is of course wrong. It should be alpha equal to 0.10, right? Not 10. Okay, so let's write on my hypothesis again. I'm going to put it on the side. I can't. Okay. So my HO versus my HA. So what I want to test is if the customers are following the recommendation. So if the mean that the cars are taking their service in is less than 32,000, right? So it is, again, the mean is less than 32,000 is my alternative because that does not include the equal sign. So my null hypothesis is going to be the mean is greater than equal or 32,000. Now the claim that I'm testing is this one. I could do it the other one. The other way I can pretend that the claim is this one, and I'm really testing if they don't follow the recommendation. And at the end, if I just write carefully, I have the same conclusion. But let's follow it this way. Okay, so I already said it's a z-test. So once I have this all I have to do is now go to my calculator. And now I select in the stat, the test, the first column has a z-test. And it asks in this order, first the hypothesized mean, which is 32,000. Then the standard deviation of the populations. Notice how it asks for sigma, right? That should bring us about that we need to have the population one, 1650. Then it asks for the sample mean, the one I got, so 33,150. And then the sample size, which is 25. There you go. And with the p-values again in the direction of the alternative. So it's in this row, it's the first number. My p-value is huge, 0.9998 if I round to 4 decimals. So of course it's bigger than alpha, and we have the same conclusion as before. Because it's greater than alpha, we do not reject H0, but since the claim is HA, we do reject HA, so the claim. We have enough evidence to reject the claim. Okay, so those are two examples of hypothesis tests using technology. One with the Z, one with the t-test.